There's some names there that I don't really know. Some
like?
people, maybe sun observers that I don't really know.
Yes, I managed to select many observations from all these observers, and I understand that there are some observers that don't usually observe all the planets, and some observers observe only Venus.
Okay, I think it's time to start. So I'm going to start with a formal introduction. So welcome everybody here again to our second session of the day one of the Europlanet Telescope Network Science Workshop. In this session, we are going to start by covering Venus, and the first speaker this afternoon for Venus is Manos Kardasis from Greece. Manos is an amateur astronomer who is very involved in activities of the Europlanet Society through the Europlanet Southeast Europe Hub of the Europlanet Society. And today he's presenting about the Venus lower cloud discontinuity from ground-based observations. And so the floor is yours and all yours.
Thank you. Hello all. We can't completely understand how the atmosphere of Venus works, but at least we can observe some phenomena and see how they behave. Maybe this can be the key to unlock some mysteries of Venus. As Ricardo said, I'm a passionate amateur astronomer, planetary observer, supporting professional amateur collaboration, and I am self-funded. Along with Javier Peralta, who specializes in the field of Venus atmospheric dynamics, and all co-authors, of course, we have worked on the newly discovered phenomenon of Venus atmosphere, referred to it as cloud discontinuity or disruption. From now on, I will refer to it as cloud discontinuity or CD. Grigoris Maravellas of the National Observatory of Athens has provided me the scientific support for this work, and of course, he has worked for many years promoting professional amateur collaboration. First of all, I would like to present the timeline of the important events leading up to this work, which it is accepted for publication in a special issue of the journal Atmosphere. Akatsuki observed the cloud discontinuity on the middle clouds of Venus in 2016. There were first amateur captures by Wesley and Phil Miles in October that year. In 2017, in the European Planetary Science Congress, I met Javier Peralta, who informed the community about the existence of this discontinuity. On November 2019, I was very happy to first capture the reappearance of the cloud discontinuity. On March 2020, it was the cloud discontinuity was very intense, and an alert was issued to worldwide observers and researchers in order to observe that event. It stimulated intense monitoring and led to the current work. The discovery and first analysis reported in the spring of that year in this excellent paper led by Javier Peralta. On the right side of the slide, you can see an image from the Akatsuki orbiter, a very impressive cloud discontinuity captured by the orbiter. Now, a few words about the Venus atmosphere. We all know that the Venus atmosphere has a main cloud deck that consists of three layers. The upper clouds that drift to the west, and it's observing the ultraviolet wavelengths, and the winds there have velocities of up to 60 times faster than the planet's surface rotation, a phenomenon known as superrotation. This is where we observe the planetary scale Y feature. Venus is observed in the ultraviolet for more than 100 years. The middle clouds, which are quite lower, are observed in the near infrared wavelengths, and we can see the morphology and the dynamics of these clouds through the images. In these two wavelengths, amateurs can observe also. The lower clouds, although, are observed in longer infrared wavelengths on night-side images only from professional instruments. The middle and lower clouds were poorly studied at lower latitudes until the JAXA Akatsuki mission. In 2016, as I said before, Akatsuki revealed the presence of a giant, a planetary scale discontinuity propagating on the middle and lower clouds. Now, we have used two kinds of observations, ground-based observations from amateurs and observations from the Akatsuki orbiter. Most amateurs make observations with 20 to 50 centimeter telescopes, and they usually use ultraviolet, RGB, and near-infrared filters, and upload the data to PVOL and ALBO Japan databases. Usually, the methodology we use is called lucky imaging, and we use fast cameras to capture videos with many, many images in them. We then use Registax or AutoStacker, a special software to select the best images and stack them in order to achieve a very high-res result. Further imaging and processing is made with Registax or Photoshop, and then we can use the WinJupos software in order to make maps, to make measurements, graphs, and derotate images in order to have even higher resolution results. On the right of my slide, you can see all the most significant observations I used for this work. And I would like to thank all the observers that are listed here for their help and for their support, giving observations and uploading the observations in the databases I referred before. We have also used observations from the JAXA Akatsuki mission, and this orbiter has 5 cameras, imaging in the ultraviolet and infrared wavelengths. Unfortunately, 2 of the cameras, the infrared cameras, doesn't work anymore. And this gap gives the opportunity to the amateurs to make observations in these wavelengths in order to fill the gap. The upper clouds are observed with 2 cameras, the LIR and the UVI imager. And we have used these images and the specialized software in order to make measurements and process further the images from Akatsuki. During the Eastern elongation of 2019 and 20, we have inspected that period from October 13, 2019 to April 25, 2020. And we have examined more than 1,000 observations where we have detected 18 cloud discontinuity events that you can see on the right panel. Now, we have the first cloud discontinuity capture, as you can see at the lower left of my image here, that confirmed the existence of the cloud discontinuity. Taking advantage of the smaller phase angle for these earlier observations, we studied the morphology and development of this CD along in several rotations through maps of time, composites similar to the ones created by Peralta et al., as you can see in the center of the image, for the night side lower clouds. The maps were made according to the average speed of the discontinuity, which is about 5 days. On November 18, as you can see here, up here, I don't know if you can see my pointer. On November 18, Venus displayed no features on the area where we would expect to observe the cloud discontinuity. On November 23, the CD seems apparent as an extension of the northern dark stripe, which was previously reported, as you can see here in the center of the image, as a cloud pattern frequently preceding the arrival of the discontinuity in 2016. On December 3, you can see that the cloud discontinuity is observed between 26 north and 28 south degrees, extending about 5,700 kilometers as an horizontal sharp dark stripe similar to those reported by Peralta et al. On the west of the cloud discontinuity, an equatorial stripe was also formed. During the last rotation, the cloud discontinuity changes inclination and a bright area follows the cloud discontinuity in the southward of the equator. Now, from mid-December 2019 and early March 2020, we have gaps in the observations because it was winter that prevented continuous monitoring. We have detected the presence of some cloud discontinuity events showing some dramatic changes in the properties, which is the speed, the size, and inclination, as we will see on the following. During March, we have an intensification of the cloud discontinuity, apparent as a vertical oriented long dark sharp discontinuity, followed by a brighter cloudy area. It suffered distortion as the day passed, and a similar event was also reported in August 2016. As you can see from the GIF on the bottom of the slide, the wave is not stationary compared to the surface. Now, as we said before, we have investigated some of the properties of the discontinuity, like the size. The size of discontinuity spanned from 31 degrees north to 36 degrees south, spanning for to over 6,500 kilometers in length and about 600 kilometers in the width. You can see that the inclination changed, and especially during the first season of the observation. You can see also the latitude coverage and the orientation, and also the rotation speed, it might be related with a change of speed. The orientation might relate with a change of speed. Now, as we talked about speed, we had to investigate the relation, the height of this discontinuity. So we made measurements from images of the UVI imager of the orbiter Akatsuki. And we made the measurements in the same dates as we made observations with ground-based telescopes. And as we can see here in this graph, we have measured the speeds of the cloud discontinuity wave from cycle to cycle. And the cloud discontinuity speeds are consistent with the manifestation of a Kelvin wave, with phase speeds faster than the middle clouds, which is the red profile, and the phase speeds are slower than the upper clouds that we measured from the Akatsuki images. Cloud discontinuity cannot be observed at the cloud stop because it becomes dissipated during its vertical propagation. Now, also we can see that the feature is not observable in the UVI images. The cloud discontinuity seems absent if we can compare the images from the same dates from ground-based images and Akatsuki orbiter. Now, we have also compared the presence of the Y feature if there is any relation with the cloud discontinuity, but it seems unrelated. It looks like there are independent waves which propagate at different vertical levels. We can see here the Y feature and the cloud discontinuity, which they seem unrelated. Now, we have also checked the stationary waves that can be captured with thermal emission from the LIR imager. And we can see that in the same period, in 11th, 16th, and 21st of March, there was a stationary wave above the Alta Regio, but this stationary wave was not observed in late March. So from comparison of the images of the LIR and the ground-based telescopes, we can see that it's not apparent in the LIR images. Now, we have investigated also some long-term evolution. We can see that from this work, we have estimated the period of the cloud discontinuity is about 4.8 days. And the mean rotation period, if we consider all observations from 2016 to 2020, it is about 4.9 days, which is the same as estimated at the previous work by Peralta et al. There are some noticeable variation in its orientation, and this discontinuity is perpendicular to the equator in March and April 2020. The mean latitudes cover from 30 north to 40 south, and we can observe some hemispherical asymmetry in this discontinuity. Now, we can see that we have some future coordinated observing campaigns, because we have the NASA Parker flyby in the 21st of August 2023 and in 6 November 2024. Of course, we have inferior and superior conjunction of Venus, so amateur observation cannot be feasible, at least in the first flyby. Now, some key points from this work. The detection and evolution of a planetary scale cloud discontinuity during 2019 and 20 was the first time after the discovery of the phenomenon in 2016. It is the first time that a cloud discontinuity is tracked and studied with ground-based telescopes. In agreement with previous reports, cloud discontinuity exhibited temporal variation in its properties and its effect over the cloud's albedo. Compared with Akatsuki UVI and LIR data, confirmed that the discontinuity is not visible on the upper cloud's albedo or thermal emission. Zonal speeds indicate that this is a Kelvin wave that might transport momentum up to the upper clouds. Amateur observations can play an important role, especially when used complementary to professional ones. I would like to thank Grisha Han, developer of Wenjupo software, for his help, the JAX Akatsuki team for providing the data, all amateur observers, and especially Raimondo Sedrani for their painful efforts. Also, Alco Japan and PVOL databases, and of course, my family and my wife, Dimitra, for her continuous support. Thank you.
Thank you, Manos. Excellent talk and excellent results. For those that are not used to look at these images of Venus on this wavelength, this is tremendously difficult because the contrast of the clouds at this wavelength is just tiny. It's really very, very small. And this feature, although it's large, its contrast is very small and it's located in a narrow region. So it's really fantastic that you have been able to observe it so many times with your telescope, and also to compile all of these observations by different people and to put all of them together, contact Javier and making all this great study. Any question from the audience?
If there is no question, I would like to ask Javier. I don't know if there is a question.
I see one raised hand, but I don't know where it is. John, you.
Yeah, I have a question. Thank you very much for nice talk and the nice images. I'm very excited to see your nice Venus study result. And my question is quite simple. So that you already made somehow team to make Venus observations. And do you think for the future, this some coordinated observation with Parker and Akatsuki, do you think this number of the teams will be able to continue Venus observations?
Of course, I think yes, but I have to say something important. You know, amateur astronomers need to be triggered.
Right.
Because observation and keeping up to date the databases, it's not their main effort. The main effort is to make images, and unfortunately they don't upload the results in the databases. This is a very, very big problem. You know, while I was searching the databases, I realized that many of the images were not uploaded in the databases, and especially in the PVOL database, where professionals usually use in order to take images. Another important problem is that when you directly see an infrared image, many amateurs don't process the image in a way that the features are observable. In many cases, I had to reprocess the image in order to find that the cloud discontinuity was there. And this is a big problem, I think. Maybe this can be a separate presentations, how difficult it was to download the database and to reprocess the image and trigger all amateurs in order to produce results and upload them to the databases.
Yeah,
so yes, I am willing to cooperate, and of course I'm willing to inform other observers, especially Venus observers, if we have some important event.
Yeah, thank you so much.
There's another comment or question by Javier. Please, Javier.
Yes, just I would like to comment that precisely last 4th of February, we have observed the discontinuity again from IRTF in Mauna Kea. In this case, using infrared images of the night side of Venus at the lower clouds. So since the phase angle is decreasing at present, I encourage amateur observers also to try to monitor the discontinuity because it has reappeared on the night side. And we have chances that it might be visible again on the day side middle clouds with this kind of near infrared images that Emmanuel has shown in the presentation.
Okay, so before we move on, I would like to say also something about Venus observations from amateur astronomers, and is that there is a high potential for scientific study of Venus with amateur observations, but the number of amateur astronomers doing Venus observations is very small. It's very difficult because you've seen the images, they are not so spectacular as in Jupiter. And so only a few people do these observations of Venus, but they are very important. Sometimes we have this kind of phenomena that is not very well known. It was discovered only a few years ago, and knowing if it happens, if of course, cyclically or not, it's important. And also the characteristics, how it changes and so on can be very important. So I think it's a good point. Try to emphasize that the community of Venus observers really wants to have more people on board. Yeah. Okay, so